queríamos hablar con vosotros de clima, pero no solo, también queríamos hacer un experimento, queremos probar a ver si podemos o sabemos establecer un canal de comunicación hoy entre los que hacen ciencia, esos seres tan extraños, y toda la gente de a pie de calle. Entonces, en ese sentido, esto es un experimento y todos formamos parte, a ver qué tal sale. El por qué nos parece esto importante son varias razones y son como varias ideas que quisiera traer aquí encima de la mesa. Una es porque la ciencia del clima tiene importancia y relevancia en muchísimos ámbitos. Estoy desde hace tiempo intentando recordar, pensar un ejemplo, algún tema científico que haya tenido un impacto tan grande en la sociedad, que lo tiene a todos los niveles, o a casi todos. Tiene importancia a nivel medioambiental, a nivel económico, a nivel político. Ya se empiezan a mezclar muchos intereses. Bueno, pues el clima es importante por esta razón, pero existe una laguna de comunicación entre lo que se hace en la ciencia del clima y el mensaje que llega a la sociedad. Y esa laguna pues está relacionada con distintos factores. Uno son los propios científicos. A veces la traducción de un lenguaje meramente científico o técnico, cómo eso llega a la sociedad, pues no es tan fácil, es complicado, y los científicos no necesariamente tienen que estar preparados para comunicar la ciencia. Eso exige una preparación adicional, además de todo lo demás que hay que hacer. Eso es por un lado. Por otro lado están los medios, que los medios pues no siempre, pero la mayoría de las veces pueden estar respondiendo a distintos intereses, porque forman parte del negocio. Entonces podemos estar hablando de titulares alarmistas o sensacionalistas, cosas así que tienen que ver con buscar audiencia. Entonces no nos podemos fiar de que todo lo que se dice en los medios, repito, no siempre, pero muchas veces las cosas no responden a la realidad. Y luego está la sociedad en sí, que se confunde porque llega muchísima información, pero ¿cómo discriminamos? ¿Cuál es la buena? Pues entonces se mezclan muchísimos factores, como estamos viendo. Pero a pesar de esa laguna, creemos que la cultura científica es importante y la experiencia dice eso. A la gente le importa saber o entender qué es lo que pasa en el mundo que nos rodea. Casi no podemos pensar en ningún ejemplo de nuestra vida cotidiana en los que la ciencia no tenga algo que ver, o un descubrimiento científico o la aplicación de carácter tecnológico. Entonces, en ese sentido, la cultura científica es importante. Pero además, sabemos que... se me ha olvidado lo que iba a decir. No, sí, era muy importante. Lo que se hace en ciencia es importante por esta sencilla idea. Veréis, a veces, cómo se llega al proceso de tomar decisiones en ciencia es particular. ¿Vale? Cómo se forma una opinión a sí mismo en la ciencia, pues se basa en distintas cosas. Se basa, por ejemplo, en proporcionar argumentos. Se trata en dar ideas que construyan una sobre la otra, no que destruyan. Y todo eso basado en evidencia, en conocimiento. Entonces, imaginar un momento que pudiéramos exportar esa manera de hacer a nuestra vida cotidiana. Sería un experimento interesante. No sabemos si eso es posible. Pero vamos a intentar hoy, por lo menos, traer una consigna aquí de cómo se hacen las cosas en ciencia para que lo probemos todos juntos. Y esa consigna es: no hay nunca una pregunta que sea tonta, porque lo que nos mueve es la curiosidad, ¿de acuerdo? Entonces, no hay pregunta tonta, sino curiosidad, y eso vale hoy aquí para todos. Y después de este rollo que os he soltado, se lo paso a Fidel, que es el moderador de esta sesión, y os va a explicar en qué consiste, ¿vale? Muchas gracias.
Hola, buenas tardes a todos. Yo soy Fidel, de la Universidad Complutense, una universidad pública. Y estamos esta tarde porque queríamos compartir, como os ha comentado Elena, un poco lo que está ocurriendo esta semana, las discusiones que hemos tenido, quizás ampliarlas un poco a otros intereses que haya hoy en el público. No se me escucha bien. Quería daros las gracias por estar aquí hoy también, no solo a los del workshop, a los amigos, a la familia, sino también a los que no nos conocen, porque incluso he ganado una apuesta de que la participación iba a ser significativa. No he perdido, no. Dicho eso, quería presentar cómo va a ser la estructura de la discusión que vamos a tener hoy aquí. Primero vamos a tener una charla breve en donde un colega, un compañero que ha participado estos días en el workshop. Va a hacer una presentación general sobre unas cuantas ideas que le parecen importantes para traeros hoy, para traer a la sociedad. Cuestiones que él cree que pueden ser merecedoras de explicarlas y que con frecuencia hay confusión en los medios, en la opinión. Después de esa primera presentación por parte de Jason, de la Universidad de Columbia, en Nueva York, vamos a tener una participación de unos cuantos colegas más del workshop. Están todos por aquí distribuidos, están un poco infiltrados de una manera diferente a la habitual. Y algunos de ellos van a subir al escenario y van a decir una frase, van a decir una idea breve. El motivo de esto es para después poder tener tiempo para discutir. Si tuviésemos a mucha gente que habla 15-20 minutos, al final nos iríamos sin discusión. Entonces, cada uno de ellos va a decir un poco una idea y después de esa idea, podéis pensar que esas ideas son como trampas. En realidad, detrás de esas ideas hay preguntas. Entonces, lo que hacemos es invitaros a caer en la trampa de esas ideas y de preguntarle a esas personas eso o otro tipo de preguntas que tengáis en mente y que os resultan interesantes. ¿De acuerdo? Esa es un poco la visión que vamos a tener. Después de eso vamos a tener una discusión y os dejaré en las manos de Laura, que va a hacer con vosotros otro experimento interesante. Entonces, le doy la palabra a Jason Smerdon, de la Universidad de Columbia, para que nos hable...
Is this okay? Buenas noches. And that will be all the Spanish I will be speaking this evening. I wish that I could speak more, but in lieu of that, I have the help of Mario, the translator, who has a tough job, but I know that he's going to do well, so I appreciate his help this evening. I also want to thank all of you for coming. I absolutely love coming to Madrid. It's wonderful for you to all be here, and this is a special experience for me to be speaking in front of some of Madrid citizens, and so this is really a special experience. I want to also thank Fidel and Laura and Elena for all of their organization and for asking me to give this presentation. As I said, it's a great privilege. And I also want to thank all of my colleagues who are here. We've been here this week speaking about science. It's been a very stimulating experience. We are enjoying ourselves. And I'm also up here as their representative. I am going to be discussing parts of our science to all of you. And so that is always a translation issue, not just from English to Spanish, but from a technical point of view to something that can speak to a broad audience. So that is in itself a challenge. I hope that I do all right with it. But they will also be here to correct me, so hopefully in the discussion, if I say stupid things, well, they can point it out, I guess. All right, so I want to address one principal question and try to give you the sense of how we as scientists try to answer it. What does the future hold? I think we all can agree that's a useful question to answer on many different levels. So when we think about that question, we might ask, why do we care? Why do we care about the future beyond maybe buying the next winning lottery ticket? There are many elements to knowing the future that could be useful. This is a quote that I like that speaks to this. My interest is in the future because I'm going to spend the rest of my life there. So knowing things about the future as best that we can be a very useful endeavor and helps us plan. If it's the weather, it helps us decide what kind of clothes to bring to Madrid. There are lots of different examples that we can think of where this would be useful. I want to give you just one serious example from my area of the world, New York. Many of you have heard of Hurricane Sandy. It affected New York, New Jersey, and the region very significantly last year. One of the tremendous things about our technology and what our science provided us as a society for this particular storm was that we knew about it in advance. We had as much as 7 days knowing that there was a strong probability of this storm affecting our region. We didn't know exactly where. We didn't know how bad, but we were able to prepare for the worst in the face of this information. Now, a lot of the facts here are what actually happened. It was still a devastating storm. There were 72 direct deaths. The total amount in property damages was over 75 billion US dollars. Many flights were canceled. More than 8 million US homes were without power. So it was a devastating storm, but imagine if we hadn't known about it. Imagine if we had not had some kind of advanced information that allowed us to plan for that storm. And there are past analogs where we didn't have that information. There was a 1938 hurricane that impacted Long Island that was also very devastating. But can you imagine not having known about the storm coming? We didn't then. We did now, and it made a difference in how we planned for it. So I want to talk about a little bit of a longer range threat and something we know pieces of information about. There are a few observations that we have over the last, let's say, 100 years that tell us something about where we're going. The first observation is CO2 levels in the global atmosphere. This is a plot of CO2 in the atmosphere in parts per million back to about the 1950s. And you can see that this CO2 has increased from about 316 parts per million, that's about 0.4%, I'm sorry, 0.316%, up to the 2012 level of 394 parts per million. Since the beginning of the Industrial Revolution, CO2 has increased in the atmosphere by about 40%. We have that observation. It's robust. We've taken it with measurements. It's something that's well observed. The other thing that we know is that temperatures at the surface of the planet and the planet as a whole are warming. What I'm showing here is global temperatures, in degrees Fahrenheit, I apologize. Forgive me. Back to 1880 through the present day. So these are temperature anomalies relative to a long-term mean. You can see that these temperatures were colder relative to the anomaly, and you can see the warming carrying up to present day. You can also see the CO2 increases relative to this record. All right? So we know that CO2 in the atmosphere is increasing, and we know that temperatures at the surface of the planet and on the planet as a whole are also increasing. We also know something about what's causing it. So this is an example of an experiment where we take those observational temperatures, again this is now in degrees Celsius, thank God, back to the beginning of the 20th century, and in black, those are those observed temperatures measured with thermometers. And these blue lines here represent climate model results, where the models have taken all of the natural things that cause climate to change and integrated them into an estimated climatic variation. And what you can see here is that the climate models match the observations very well until about the middle of the 20th century. There is no way, given just the natural causes, that these models match the observed temperature record. It's only when we include those natural things that cause climate to change, like solar variability, volcanic events, etc., and add them to the anthropogenic changes, the human-caused changes, the CO2 increases in the atmosphere, that we can match very well the observed temperature record. So this is an example of how we associate cause. To sum these three slides up into a much more straightforward statement, we know the Earth is warming and we're causing it. Let me say that again. It's not a controversial statement. My colleagues here can agree. The Earth is warming and we're causing it. So if that's what's happened, how do we, as scientists, think about what the future will hold in light of this evidence? So how can science tell us about what the future holds? And what I'd like to do is give you two examples of how we might use scientific knowledge and evidence to make predictions about the future to the best that we can. Is there any way we can get, well, I guess I need the light on me. So one way that we do this is through our knowledge of basic physics and chemistry. There have been centuries of science that have helped us understand the physics and the chemistry involved in how climate and the climate system varies, the basic equations that define how mass and energy moves through the Earth system. And we know a lot about that. This is a picture of Newton and a lot of Newtonian mechanics and what Newton discovered many centuries ago are things that are still applicable today that we know, that not only help us understand the climate, but help this microphone work, or help you use a remote control with your TV. So we know a lot about math. We know a lot about math, but we also know a lot about physics and chemistry. And we can use that knowledge in climate models. We can plug that into these large mathematical models that incorporate all of our knowledge about the physics and chemistry of our planet. And we can use those as ways of projecting into the future if we make assumptions about what the future might hold in terms of the actions we make, etc. But all a climate model is all of the physics and chemistry put into a mathematical model of a world that's split up into little different squares. So this figure is showing the squares of the atmosphere. We have squares in the ocean, and those squares contain the equations that define the math and the chemistry and the physics that we use to model the climate. Once we do all of the math and physics, we then just let computers do the accounting. So once we create these large mathematical models, these physical models that describe how climate changes, we use very large computers, better than this one, to calculate how climate changes and how it might change into the future. Now, it's not perfect. We divide space into blocks that aren't perfectly finite. We have lots of uncertainties in how the future might unfold. So these climate models aren't perfect. They contain different elements of uncertainty based on our imperfect knowledge of how the world works, based on the imperfect way in which we can represent space and time with these climate models that are cut up into little squares. So there is uncertainty, and I want to talk to you briefly about those elements. But I want to speak also about the biggest uncertainty about the future. There's uncertainty associated with the physics and chemistry that we represent in these models. But there's also lots of uncertainty about the decisions that we will make moving forward. How will we get our energy in the future? How will we use that energy? How many of us will be around using that energy that we get from somewhere? These are things about the future that we don't know with certainty. So the best we can do is make estimates, decisions about maybe we'll get our energy from this source into the future, and we can create scenarios. We can make estimates about how the human population will change into the future. All of those things we can use to create scenarios that are suggestive of different paths into the future. So we can't predict it. We can't say that it's going to be this way, that there's going to be X number of people in 2100, etc. But we can make decisions about scenarios that might play out in different ways. Now, when we do that, and we look at the uncertainty inherent in the climate system, it has a lot of its own natural variations and so on, and we consider the physical uncertainties with our knowledge of the physics and chemistry that go into the models, and we also acknowledge these human uncertainties through different scenarios. These are the projections that we have into the future. So this is the temperature change relative to 1986, 2005. These are those observations that I showed you previously that we know to have occurred over the last century. And this is the spread of possibilities into the future given these different sources of uncertainties and assumptions about scenarios. When you look at where we may end up in 2100, the temperature change that we project as possible is between 0.3 degrees Celsius and 4.8 degrees Celsius. What I want to point out is this is a very unlikely scenario in which we actually begin removing carbon from the atmosphere. This is much closer to what will happen if we continue without making any changes. The important thing, however, that I want to come back to is when you look at these uncertainties, the range of uncertainties in terms of what temperatures we will ultimately end up in have most to do with the scenarios, the choices that we make about the future, and that's a very important point. That being said, we know that should the CO2 continue to increase in the atmosphere, we will warm, and the amount that we will warm depends very much on the decisions that we make. Okay, that's one way that we can project the future, through our understanding of math, physics, and chemistry, and using climate models along with assumptions and scenarios about the future to give estimates on the changes we expect. The other thing that we can do, and what many of my colleagues and I have been doing this week, is think about the past. We know a lot about past Earth history and how the climate has changed in the past, and we can use that as a guide for testing what we know about the future, for comparing, for instance, to these model estimates that we have. So this is a Winston Churchill quote: "The farther backward you look, the farther forward you are likely to see." This is something that we as paleoclimatologists like to think is certainly true. Okay, so I'm just going to give one example of looking into the past. This 400 parts per million number is the average level of CO2 that we will reach in the atmosphere in a few short years. It is also the daily value that we passed for the first time a few months ago. So 400 parts per million, 0.4% CO2 in the atmosphere. If that doesn't sound like much to you, consider this. If a person like me drinks 2 beers, which is typical, my blood alcohol content will be approximately 0.4% alcohol. 0.04, sorry. That zero is important. Same as the 0.04% of parts per million. And that's the point at which the human body just begins to start feeling the effects of alcohol. So that's an example of a small trace amount that can affect a much larger system. It works not the same way, but it's something that we can think about with regard to our planet in the way that small amounts of CO2 can impact the radiation balance and therefore our surface temperatures. But the story I really want to tell you is about the last time the planet was at 400 parts per million CO2 in the atmosphere. Any guesses as to when that was? Besides a couple months ago? Well, it happens to have been about 3 million years ago during a time called the Pliocene. And when we look at Earth history, it's true that there were past periods when CO2 was at the levels that we've had presently, and temperatures approached levels that we have presently or higher. So during the Pliocene, at this time when the temperature was, or when the CO2 was 400 parts per million higher, the temperature of the planet, can't see that, but it was about 2 to 3 degrees Celsius warmer. So at a past time when CO2 was at the present levels, we were about 2 to 3 degrees warmer. The other thing that we know about the Pliocene is that sea level at that time was about 25 meters higher than it is to present day. Some of you may recognize this building. It's the Flatiron building in my city. And that's roughly 25 meters up from the ground on this building. So we know that sea level was much higher, and we know that temperatures were also much higher. And this is an indication that this experiment has already been run on the planet in certain ways. And we can look into the past and see what happened with that experiment and compare it to what we also know from our climate models. And when we start looking at these things, it's consistent that the past, when it was like it is presently in terms of CO2 levels, it was a much different planet. Often what we see when we look into the past, as I've said, is that the world has been warmer, or as warm as it is in the present. But the other important truth, when you think about sea level rise, 25 meters higher than it is today, was that the world was a very different place at those warmer times. So we as a society will have to deal with those changes that, in this case, we bring upon ourselves because of the warming that we're inducing through the CO2 changes. So this is what we can say about the world ahead of us. What is certain is that the planet will continue to warm with increasing greenhouse gas emissions, and the warming will bring many changes. Where we land in this spread remains to be seen. There is uncertainty, but we know that with increasing greenhouse gases, the planet will continue to warm. What is uncertain is that we're not sure how big the changes will be because we don't know all of what will happen in the future. But we also don't know if we're ready for them. I would argue that if things continue, we're probably not. And how much do we want to work to avoid some of those most serious changes? Those are questions that scientists can give information on, but ultimately it's up to all of us to make those decisions and try to reduce some of the uncertainty about the kind of world that we want to live in moving forward. So we were supposed to provide provocative sentences. This is mine. Actually, it's not mine. It was by Nobelist Sherwood Rowland. And I want to leave you with this challenge to think about. What's the use of having developed a science well enough to make predictions if in the end, all we're willing to do is stand around and wait for them to come true? I would argue that as a community, as a society, we've invested a lot of money and understanding to help us understand what the future is going to bring. We have this information at our fingertips. It's out there. There are scientists working very hard to understand these things. And we have provided the world with lots of information that now all of us have to decide how to act on. But I will remind you that the world is warming. We're causing it, and we can expect more changes into the future if we continue with our business as usual scenarios. Thank you.
Muchas gracias, Jason. Yo creo que había varias frases e ideas provocativas en esa charla que nos pueden hacer pensar y con las que ahora podemos disfrutar de una conversación interesante. Además de Jason, hay unos cuantos colegas que van a subir aquí al escenario a compartir esas ideas. Van a decir algunas ideas más provocativas o que creemos que lo pueden ser y que, como antes comentaba, están planteadas para que penséis en ellas, para que caigáis en esa trampa y a ver qué decís. Entonces ellos se irán presentando a medida que vayan diciendo sus frases. Tenemos a Lucien. Podemos subir al escenario. Steven. ¿Ya? Christoph. No tenemos que ser muy formales, podemos subir del tirón. Bronwen, Mike, y Johan, y Jason. Entonces, podemos empezar en una secuencia de ideas. Cada uno dirá algo para haceros reflexionar y quizás os comentará con unas cuantas palabras. Y sin solución de continuidad, seguimos. Lucien.
Lucien.
Thank you. Good evening. It's a pleasure to be here. My name is Lucien von Gunten. I'm from Bern in Switzerland. I would like to come back to one topic that Jason has talked about, is the past, how climate has changed in the past. And my sentence is, the climate has changed in the past. There were times, billions of years ago, where Earth was so warm that life was not possible on Earth. But there were also other times where most of Europe, or even the world, was under a thick layer of ice. So we had warmer periods and colder periods in the past. The big difference is that we were not there back then. So the Earth doesn't really care about it being warmer or colder. And nature will adapt eventually. But the question is, can we adapt?
Gracias por esa. Mike. Steven, sorry. Steven goes first.
Ok, buenas tardes. Mi nombre es Stephen Phipps y trabajo a la Universidad de New South Wales en Sydney, Australia. Todos los modelos están mal, pero algunos son útiles. Gracias.
Gracias. Yo soy Michael Evans de los Estados Unidos. Soy profesor en Universidad de Maryland, cerca de Washington, D.C. Mi sentencia es, como Jason dice, mucho con mucha confianza. Y Me gustaría decir que en las ciencias naturales nunca hay pruebas. No nos probamos nada. Solamente hay que rechazar hipótesis.
Muy bien. Se supone que yo también tengo que decir algo después de Mike. Entonces yo diré que ese proceso establece una forma de diálogo. Y me gusta decir que también de cómo se llega a consenso. Y esa manera no es una forma no es un método basado en opiniones, como antes decía Elena, sino en argumentos. De hecho, puede resultar no democrático, en el sentido en que los consensos no se alcanzan por mayorías o por votación, se alcanzan de otra forma, examinando, evaluando la evidencia que hay y el grado de acuerdo en esa evidencia. Christoph.
Okay, so my name is Christoph Reible. I'm also from Bern, and I'm there in the physics department, working also with climate models. And I will pick up the statement from Mike, and I would add to that there's often in the society and in the media a misinterpretation of what we understand under a scientific theory. So the scientific theory is the highest competence which we can get in science. It's nothing like impossible, or sometimes it's used like disgraded if we have high confidence in something.
Muchas gracias. Hoy además tenemos una artista invitada especial, que es Marisa Montoya de la Universidad Complutense. Así que me gustaría invitarte a que subieras aquí arriba. Y tenemos otro artista especial, que también es español, trabaja en Alemania y que se llama Eduardo Zorita. Y que los he dejado para el final para hacer un poco más de énfasis. Ellos son los que van a decir algunas de las frases más provocativas. Y me deben una cena. Marisa.
Bueno, yo voy a referirme a algo que yo creo que todos los que estáis aquí ya habéis oído, que es la respuesta que dio Mariano Rajoy, presidente del gobierno actual, hace unos años cuando se le preguntó acerca del cambio climático. Él dijo que él no sabía mucho de eso, pero que su primo era catedrático de física y que la contestación de su primo era que si no somos capaces de predecir el tiempo a unos pocos días, ¿cómo podemos querer decir nada acerca del futuro, dentro de 300 años?
Bueno, Jason ha enseñado ya que algunos o muchos cambios que se observan, sobre todo en la temperatura de la Tierra, se pueden atribuir a la actividad del hombre. Sin embargo, no todos los cambios que se observan están causados por el cambio climático. Y hay casos en los que, bueno, los resultados científicos indican que no existe esa relación. Un ejemplo son los huracanes. Y muchas veces se hace esa relación entre huracanes intensos o tormentas intensas y cambio climático que no es científicamente correcta y que se verá, o se está viendo que no es, como digo, no es correcta y que luego puede ser utilizada por los escépticos para destruir toda la teoría sobre el cambio climático.
Y finalmente, Johann.
Yeah, good evening. My name is Johann Jungklaus from Hamburg in Germany. And I would like to extend a bit on this last slide of the presentation and the point that Jason makes that what the future will bring us will depend very much on us, on societal choices. And I would like to pose a question to the audience. What should the role of the scientist be in this choice? Should we just still sit in our offices? Should we cry out loud, or should we even give more power in decision making?
Gracias. Y más finalmente todavía, Bronwen.
Me llamo Bronwyn Konecki, soy de los Estados Unidos, a la Universidad Georgia Institute of Technology. Y quería decir que el cambio climático es sobre el clima medio, pero ustedes y yo no vivimos en el clima medio. Ayer hizo frío, mañana no sé. Pero eso es el tiempo, no es el clima.
Gracias. Gracias a todos. Y nos queda... me olvido.
Hello, I'm Hugues Gauss. I'm coming from Belgium, from the University Catholique de Louvain. And my sentence would be related to CO2. We talk a lot about CO2, but climate can change for many reasons. It could be due to solar impact or to change in the orbital of the position of the Earth compared to the Sun. And so why are we so sure that it's not something else than CO2 that induced the recent change?
Gracias. Ahora sí que todos hemos dicho algo. Y estamos a la disposición del tribunal para las preguntas que nos quiera hacer, que es algo que se dice con frecuencia en la universidad. Así que no queremos ser demasiado formales, así que de la charla de Jason, de las preguntas que han surgido después, de las ideas que han surgido después, de vuestras propias motivaciones, abrimos sesión. Si no, tendré que recurrir a algún amigo para que rompa el hielo, o familiar. ¿Alguna preguntilla, por favor?
Hola, buenas. Pues solamente quería preguntar si les dieran a ustedes el poder político o el poder mundial, ¿qué harían? ¿Qué empezarían haciendo? Claro.
Mejor que no. ¿Un voluntario para contestar?
The speaker has the first one.
I'd first make airplane seats bigger. I think there's lots of good ideas about how to respond to this challenge. First and foremost, reducing carbon in the atmosphere is what we have to address. No matter what we do, that is the principal problem that stands before us. That will continue as carbon increases in the atmosphere, that will continue to warm the atmosphere, and that will bring about many changes. So I'd say that no matter what we do, it has to address that. But there are a tremendous number of options for doing that. There are a lot of smart people working on technologies that will make our world more efficient, allow us to exploit renewable energies in effective ways. And I think that those are all things and choices that are in front of us. I would certainly make sure that the conversation we're having is how to use those technologies, what decisions to make about that to address the challenge in front of us. I wouldn't spend my time debating about whether it's a problem, because I think that the resounding message from the scientific community is that the future will bring with it many problems if we continue in the direction that we're going. The other, can I still talk? The other thing that I would say is people often ask me, are we going to deal with climate change? And the fact of the matter is, we're going to deal with it one way or another. So in addition to working to mitigate the most extreme changes in front of us, really keeping the CO2 levels in the atmosphere from going to extreme levels, we have to acknowledge that adaptation is going to be a problem and something that we're going to have to address as well. Sea level rise will continue. There are lots of challenges to our infrastructure that will come about through the expected climate change no matter what we do. Most of the decisions that we make won't affect the climate significantly over the next several decades, but it will have a huge impact on what we do or what the climate looks like towards the end of the century.
Maybe to add to the background to my question, actually, the response would be, would it really be a good idea to give us the power to do that? And it's just not, so we would probably have an answer how to reduce CO2, but this has to be put into a discussion. So I'll give you an example. So one part of the recent climate research was the question, can we reach a goal to have global warming not more than 2 degrees from pre-industrial? We have half of that achieved now. And it turned out that it is possible if we take measures, but the scenarios that are kind of prepared for that, they are problematic. They would mean, for example, that we have to go to nuclear power, we have to carbon sequestration that are all processes and things that need to be discussed really in the public with all the consequences.
Hola. I wanted to talk.
Sí,
Sorry.
Digo algo también es que hay cosas para hacer fáciles y algo cosas que están más difíciles. Empecemos con las cosas fáciles y después pensamos en las cosas más difíciles.
¿Más comentarios? Bueno, esta va de provocativa. Dejando de lado el hecho de que, de acuerdo con las simulaciones y con las proyecciones, el nivel del mar va a subir, digamos, entre 1 metro y, bueno, las cifras que aparezcan en un nuevo IPCC. Dejando de lado la subida del nivel del mar, si suponemos que para el año 2100 la temperatura media del planeta sube entre 2 y 3 grados, con un efecto de amplificación polar y tal, ¿por qué eso para la humanidad es catastrófico? O sea, uno podría pensar que 5 grados más en Siberia no haría sino más habitable la Tierra para los humanos. Incluso si vamos más allá y quitamos el hielo en la Antártida y podemos plantar cereales y tal, y teniendo en cuenta que la curva de la humanidad es exponencial y que para dentro de 100 años a lo mejor doblamos la cantidad de humanos en la Tierra, desglaciar la Tierra no parece mala idea para hacerla habitable para los humanos. Ya decía que era provocativa, pero... Sí.
Bueno, empiezo con un comentario corto y a lo mejor luego mis colegas quieren comentar también. La diferencia de temperatura media entre Madrid y El Cairo son 5 grados. O sea, si tú ahora, bueno, usted supone que aumentamos la temperatura de Madrid de tal manera que se convierte en El Cairo y los recursos hídricos también. ¿Podría una población como Madrid y todo el sur de España ser sostenible en esa situación? A lo mejor sí, a lo mejor no. No lo sabemos.
Yo voy a añadir algo, aunque yo creo que la persona que lo ha preguntado lo sabe mejor que yo. La diferencia entre la temperatura media actual y la glacial está en torno a 5 grados. Y uno se puede hacer idea, digamos, a la inversa de qué supone eso globalmente, de qué magnitud es el cambio. Y bueno, otra cuestión también es la tasa a la que eso ocurre, o sea, la rapidez con la que eso está ocurriendo. Si es posible adaptarse digamos, al cambio tan rápido.
Thank you for your good question. So, I'm from Switzerland, so if you talk about sea level rise, I don't really care too much. It will never rise up to my feet up there. But this brings to the point that it really depends where you are. And so in many countries, for example, or in some countries, in Greenland, for example, as you say, they probably won't mind if it gets a bit warmer, if they can start cultivating, if they can get more easily access to the soil resources they have, mining or so. But this 1 meter sea level rise that you mentioned, if you live in a country like Bangladesh, where you're very close to the sea, and most of the cities are close to the sea, and you don't have the money like maybe they have in the Netherlands to build big dams, then in fact, yes, it's really affecting you very much. To come back to Switzerland, in Switzerland, as I said, sea level rise is not a problem, but one problem we're facing is, first of all, that the glaciers are disappearing, and in summer, most of our water, not only our water, but going down the main rivers to many of the European countries, in a dry summer, most of that water come from the rest of the snow and from the glaciers in the mountain. So if we don't have the glaciers anymore, it will be a big change in terms of our hydrology. And another thing that is happening is that the permafrost is melting in the mountains. This means that the ice is acting like glue and holding rocks together. And now when this is disappearing, there is much more landslides and stones coming down when there are extreme events. And there are actually now people that have to leave their houses in the mountains because the house is threatened to be destroyed by landslides. And the geologists, they see that and they say, you have to leave your house. Sooner or later it's going to be destroyed.
I'll just make a brief comment to that, which is that something that we're still trying to understand isn't just how temperature will change in the future, but how rainfall will change. And temperature influences rainfall all over the world, and there are some things that we think we are starting to understand, but there's others that we haven't considered yet, and some things that are still very uncertain. So, and rainfall is something that affects everybody on this planet. And one other point is that there's also things that we maybe didn't anticipate that are going to be consequences of global warming. And one thing, I work in Africa, so an example that is happening there is that people who live higher up in the mountains there used to never be affected by malaria. And now malaria transmission is moving further and further uphill because warming is starting to influence where the mosquitoes can live. And so that's not something that people really thought about necessarily when they started talking about global warming, but that's a really huge impact on people.
Bueno, antes de mi pregunta quería hacer un comentario que me ha venido a la mente con esta pregunta que estáis ahora discutiendo, que es también el factor humano, ¿no? Quiero decir, si a veces los humanos por un pedazo de tierra se meten en una guerra que dura años y décadas, ¿qué pasará si media población mundial tiene que emigrar a otra parte del planeta, ¿no? Bueno, mi pregunta es, ¿cómo valoráis la comunidad científica las medidas que los países han estado tomando en este tema en los últimos 10 años, en cumbres climáticas, iniciativas de política energética? O dicho de otro modo, ¿sentís que vuestro trabajo tiene un impacto a nivel de diseño de políticas? La importante realmente es la segunda. ¿Sentís que vuestro trabajo, vuestro desarrollo científico, los resultados a los que llegáis, los modelos que tenéis, los informes, tienen un impacto en las medidas que toman los políticos, las medidas a nivel mundial para luchar contra el cambio climático?
I'm not sure it is having a massive impact, but lots of countries and lots of places are trying to develop mitigation strategies. For example, the UK, where I work, we have targets to reduce carbon emissions by a significant amount by 2050 or something. And so there is some policies, but it is slow in coming. Anybody else?
An additional important point is that not only the policies should change according to what we are saying, but the behavior of individual people are changing. And one evidence for that from my point of view. If you can look at many advertisements on television, they say, yes, it's green, it's good for climate. It's not always true, but it means that it's something which is going on and it's much more important. So there is, on one end, the policy that are imposed to people, but there are also the choices of many people. And that's also something where we have the feeling that what we say is listened at least by a part of the population.
Soy de los Estados Unidos y creo que podemos hacer más los americanos. Y también puedo con Hugo que nosotros individuales necesitamos hacer más, cada uno.
Yo tengo una pregunta. Marisa, has sido tú, has sacado el término glacial o interglacial, creo que has dicho algo relativo a eso. Y eso me trae a la cabeza que, por ejemplo, con los estudiantes la semana pasada, la gente se pregunta sobre el cambio climático y uno de los argumentos para decir que no lo hay, es decir, que ha habido antes, lo habéis dicho antes también por ahí, ha habido antes en la historia cambios de magnitud mucho más grandes, por ejemplo, de aumento de temperatura que el que estamos experimentando ahora. Es decir, que el clima ha sido muy cambiante y por tanto no hay razón para ser alarmistas o para creer en esto. ¿Y vosotros cómo le explicaríais, por ejemplo, a los estudiantes, o si te lo pregunta tu madre, que el clima varía, pero que esto es distinto, que esto que estamos pasando ahora es nuevo? ¿Cómo explicaríais vosotros eso? ¿O a vuestros chiquillos?
Bueno, no sé si debo responder yo a esta pregunta, me lo has hecho a mí directamente. O sea, yo diría que sí, que es cierto, que bueno, esa es la razón por la que la gente que está aquí está estudiando el clima del pasado. El clima ha cambiado en el pasado, pero las razones de ese cambio son diferentes a las razones del cambio actual. Las razones de ese cambio se entienden en muchos casos, digamos, el clima ha cambiado a diferentes escalas temporales y en muchos casos entendemos por qué es así. Y los cambios que estamos viendo ahora son básicamente las diferencias que están producidos por el hombre. Eso no había ocurrido previamente. No sé si eso responde a la pregunta. Seguro que alguien la puede completar.
I completely agree. I think that the difference is cause. As I said in my talk, it's been warmer in the past, but the human impact is what makes this different presently. And if it's us that's causing it, and we know that it will present a lot of difficult adaptations to us as a society into the future, we can change that. If we are the cause, we can stop that if we want. If you're hitting yourself in the face with a hammer, you can stop doing it. So the point is that because we are the cause of these changes, we have the opportunity and the knowledge, the understanding of what to expect in the future if we continue doing what we're doing. And so therefore we have a choice about making a change. And so I think that, again, the cause is the most important thing. We are causing it, and certainly moving into the future, we start to get to levels and rates that maybe don't have a lot of past analogs. And that's the other, perspective that the past provides. We are beginning to move out of, ranges, especially in terms of the rate of warming that have been seen in the past in many cases.
One friend gave me once an analogy. Of course, it's not science, but I found it was interesting analogy, explaining that the majority of the people are dying because of diseases. But if you are a lawyer, if you go to a court and say, yes, my client has not killed that person because the majority of the people are dying because of diseases, it will not stand. So there are many reasons that climate could change, but that doesn't explain or justify that man is not the cause of the recent changes.
Hola, lo que yo muchas veces he hecho en falta en estos debates es que no se suele mencionar los sacrificios que habrá que hacer si quiere uno cambiar y parar el cambio climático, ¿no? Porque pues, no se suele decir que yo creo que es bastante probable que si cambiamos y intentamos tomar medidas, pues no podemos volar tan barato como hasta ahora, o el precio de la gasolina será mucho mayor que ahora, o el precio de la electricidad será mucho mayor que ahora. Y eso es algo que a la gente de la calle por lo general le preocupa mucho más que lo que ocurra dentro de 50 años, sobre todo en la situación económica actual. Entonces, ¿qué le dirían ustedes a estas personas? ¿Cómo les convencerían teniendo en cuenta que a ellos les preocupa lo que ocurre ahora y no lo que ocurrirá dentro de varias décadas? Sobre todo teniendo en cuenta que afecta a su bolsillo, que es lo que más preocupa a todo el mundo normalmente. Gracias.
Muchas gracias. Interesante. Edu.
Bueno, como en todos los problemas políticos o sociales, la solución es difícil porque una parte de la sociedad tiene que pagar más y otra parte de la sociedad se beneficia. Entonces tiene que haber un proceso de negociación social sobre cómo resolver el problema. No es algo que solo ocurra en la cuestión del cambio climático, sino en todas las cuestiones sociales. O sea, no es nuevo. Como es muy difícil, como es un problema que nosotros pagaríamos ahora y se beneficiarían nuestros nietos dentro de 100 años, pues es tan difícil de resolver. Hay gente que propone otras vías diferentes a las políticas que se han seguido hasta ahora, que conectando con la pregunta que se hacía antes, realmente no han llevado a ningún éxito constatable. Las concentraciones de CO2 siguen subiendo como antes. Entonces hay un grupo de políticos o de economistas, de sociólogos, que proponen otras soluciones, que es, por ejemplo, incentivar muchísimo más la investigación tecnológica en vez de, por ejemplo, aumentar los impuestos sobre las emisiones. O sea, hay otras medidas que se han propuesto y que a lo mejor habría que pensar en si podrían ser más útiles.
There's also a whole working group of the Intergovernmental Panel on Climate Change trying to figure out how much it would cost to change our energy policy, what would it even take to fulfill our energy needs, what can we do and how much would it cost and what would be the consequences. So there's a large group of economists trying to figure out how we can handle climate change without destroying our economy. And I think it's a really important question to look at both climate change and also how to realistically deal with it.
A mí me gustaría hacer dos comentarios. Uno es que es evidente que es importante analizar el coste, pero quizá más que analizar el coste habría que preguntar quién lo tendría que pagar o a quién beneficiaría, ¿no? Porque al final quienes toman las decisiones son unos pocos. La pregunta que se hacía anteriormente, que iba dirigida hacia el individuo, creo que se podría cambiar de escala y dirigirla también hacia los estados, hacia las corporaciones, hacia los que toman las grandes decisiones, ¿no? ¿Cómo los convenceríamos a ellos de pensar en los demás? Realmente hoy en día hay muchos otros problemas que provocan muertes y daños y las decisiones se toman para beneficiar a unos pocos. Es evidente que gran parte de los países más cálidos son países muy pobres y que no les importan mucho, ¿no? Y los que tienen medios y recursos y poder siempre pueden sobrevivir, siempre pueden moverse a las zonas más prósperas, siempre pueden aprovechar que el deshielo para extraer más petróleo, siempre pueden sobrevivir. A ellos no les importa tanto esto, quizá, es lo que a mí me parece.
¿Alguien quiere añadir algo a este comentario? Anybody wants to contribute on this one?
Hola, buenas tardes. Bueno, en primer lugar quería felicitar a todos los participantes en este foro porque creo que es muy interesante y que haría falta más encuentros de este tipo para mejorar la comunicación de la ciencia del clima, y con esto enlazo con mi pregunta. Yo creo que existe una batalla, por un lado, entre lo que es la corriente principal de la ciencia del clima, representada por todos los científicos que forman parte del IPCC, que imagino que serán muchos de ustedes, de los que están aquí presentes hoy. Y luego, por otra parte, hay un grupo reducido de científicos, incluso me atrevo a llamarlos pseudocientíficos, que no consiguen publicar sus trabajos en revistas científicas de impacto revisadas por sus pares y que, sin embargo, sí que consiguen hacer llegar sus mensajes a la sociedad y con éxito. Entonces, yo tengo dos preguntas. En primer lugar, quería saber qué opinan ustedes de esta situación, a qué se puede deber, por qué se está perdiendo la batalla en la comunicación de la ciencia del clima. ¿Por qué tienen más éxito los científicos o pseudocientíficos escépticos? Y, en segundo lugar, quería saber si me podían contestar si existe algún tipo de estrategia, si se está diseñando algún tipo de estrategia en el seno del IPCC para mejorar la comunicación de la ciencia del clima a nivel global. Porque yo creo, desde mi punto de vista, que para que se tomen medidas políticas, en primer lugar, tiene que haber una aceptación por parte de la sociedad y que se reclamen esas medidas políticas, porque si no la política se va a mantener, digamos, inactiva y va a seguir un poco obedeciendo a lo que son los intereses de las grandes corporaciones y del sistema, digamos, de los grandes oligopolios energéticos, que al fin y al cabo son los que de alguna manera vertebran lo que es el desarrollo económico actualmente. Muchas gracias.
So, who takes this one?
Maybe I can pick out one of your points you said. I think, first of all, it's maybe we have to be quite clear about what we have in the scientific discussion. We have people who are skeptical, and in science, to be skeptical is good, because it's really important that we have people who request our results, who redo our results to check it. Now, what you are referring to is more a community of people, some of them are pseudo researchers or scientists who are mainly denying climate change. And they get, I think especially in the US, a certain attendance, and also in the media, because media likes to have these, pro and cons. And I think we have no other method than just presenting our results and show that we have evidence in it. And sooner or later, I think these people, there are some smarter behind them, they will change their opinion. So I would say most of them, they will now say, okay, there is climate change. We see that in observations, because we have observations, and it's hard to argue against that. But they will then say, well, you see, in the future, the costs will be less. So they go to the next level, saying, well, the cost is an issue. And I may add up to the cost issue. We not only have costs, we have also other things happening. So if we lose species, if we have deaths due to climate change, you don't want to cost that. You don't want to pay a price on if your grandfather dies because of a heat wave. That's not what you would like to do. So there are a lot of other things, impacts happening in climate, which might be related to climate change. And there, I think, it's not only costing in a way. But it's clear we have this problem with this small community, and the motivation of them is, well, it's hard to treat. Yeah? Well, I would say a personal view of mine is they are mainly driven by economic, say, think tanks behind them. which would like to keep the carbon like to say, keep into business in a way. And we have to find a solution also for example, the oil companies to keep into business. Because it's clear that the oil industry would like to survive. So we would not have, well, I think that the politicians, at least from some of the countries, will not say, well, we will stop that. That's for sure. It will not happen in some of the countries who rely fully on oil. So we have to find solutions to deal with that. And this is, I think, something which we, as a society and as a global society, needs to solve in negotiations.
Cuando estoy discutiendo este problema con mis estudiantes, es para mí más importante que los estudiantes están pensando que cuál o qué ellos piensan. ¿Entiendes?
I just want to address a couple questions that you had. One was, is the scientific community addressing this communication issue? It is. For instance, we go to international meetings now where there are entire sessions devoted to science communication, how to communicate science to the public, how to educate the public about a whole range of scientific issues, not just climate change, but to communicate to the public what we're doing and what's important about the science that we're achieving. So there is a wide recognition of the need for that. It's also recognized specifically within climate change that scientists can do a better job at communicating. We all can learn how to communicate what we're doing more effectively. It's hard. It's hard to tell each other what we're doing sometimes, let alone explain to the lay public about what we're doing if they haven't been trained in the same areas that we're being trained in. So there's a lot of work for us to do in that area. But I think the other point that you make is that it's not just a vacuum that we need to enter into. There is a lot of noise and discussion that some of it is healthy and some of it's the debate about what this all means. It's going to be a difficult task to address climate change. There's a lot of difficult decisions that we have to make. But there is also a lot of discussion that's intended to confuse people. And in terms of what Mike is saying, I think that there has to be a heightened awareness of that as well. The way that it's reported in the media, as well as the way that we as citizens digest the information that we're receiving. We have to recognize where our information is coming from and what it represents. And so as a citizen, you can think about where you get your information. The media is an important place for that. But we also have many organizations and institutions. In the United States, we have the National Academy of Sciences. Internationally, we have the IPCC. These organizations that represent the consensus view of the scientific community. There's lots of things that we disagree on, but there's also many important things that we know to be true through our science that represents enough information on which to act as a community. So that's another important element to understanding where scientific information is coming from and what it represents, because it is a very noisy place and there's a lot of doubt that's spread intentionally, and there are many reasons for that. And so as scientists, we're not just going out communicating in a vacuum. There's a lot of competing information, and it's tough to cut through that, through to the basic things that we know and we think are important and relevant.
I would just add to Christoph, I think this battle of interest will go on. Up to very recently, I was thinking, yeah, probably don't have to care very much about it because we have to get out of carbon anyway. So there should be a general societal agreement on that. But just now, the newspapers tell us that they find it now a risk that energy is too cheap. So this kind of say for going out of the carbon, we just have the reason that we do that for climate, not to keep our industry running. And so that will make really the interest of the oil companies, of countries who produce oil, much stronger, and they will more strongly opponent this climate change debate.
I think something that's really exciting about being a climate scientist is there's so many people who are interested in climate change. And I can tell you, every wedding I go to, I tell somebody I study climate change, and they want to talk for hours about whatever questions they have, which is really nice. And I will say that if you want to talk to me about the Asian monsoon, I will talk to you all night about it, and I'm really excited about that. But I think that in the same way, you know, if you're a doctor and I'm really interested in heart disease, there's my opportunity to ask you all about it. And I think the thing that is an opportunity for all of us is that it's been a strategic initiative for people to raise a lot of questions about climate science and to act like there's really a debate about whether climate is changing or whether we're causing it, when, you know, there isn't much of a debate at this point. We know those things. So I think it's an opportunity for all of us to seize the moment when people are interested and to start being optimistic about it and saying, yes, there are things we can do, and I'm so glad you're excited about it. And the next time that you talk to somebody at a wedding, go let them know that, you know, here are some resources where they can learn about climate change. And if they don't care at all, which is fine, then they should just start to understand that experts are experts in their particular fields. And I'm not going to make policy decisions about heart disease, but I will fully trust the people who are capable of doing that. And I think as citizens, you can demand that. And you can demand that of your government. And I'm an American, so this is, you know, an issue in the US especially. But I think that you can demand that the people who you're voting for actually pay attention to who is an expert and who is not, and who is in it for economic reasons, and who is really just a scientist who's really excited to talk about it.
Okay, I'll just add a couple of quick comments going back to your original point about doubt and communication. I think it's important to understand that asking questions is one of the defining characteristics of science. But on the other hand, you know, we're scientists, we're meeting here to look at the evidence from past climates, and when you look at the evidence from past climates, and, you know, that provides the context that makes it very clear that there is a human influence on the climate system and that climate change is real. And when you have a situation where I think some people are trying to create false doubt about the state of the science, that does, I think, create an obligation on the scientific community to communicate the truth about the science directly to the people. And I think all of us all try in our own different ways to communicate the science that we can through all the means available to us. But I just want to say, I think it's wonderful that there's so much passion about the science that so many of you will come out on a Tuesday evening to listen to a bunch of us boring old scientists talking about science. So thank you.
I think a lot was already said. I'm Betty Otto Bleasner. I'm from Boulder, Colorado, and I'm here at this meeting. And I agree, we could communicate better. Sometimes we get into our own language and our own technical things, but I also was confused for a number of years because I've explained it to my mother, and I've explained it to my mother-in-law and my children, and they understand. And we have a dialogue. And what I realized a few months ago is I went to an event like this in Aspen, Colorado, where we had a meeting discussing these things. And I realized it wasn't how I was explaining it. It was a very good presentation by some of the scientists in the group. There were people that had chosen not to believe for other reasons. And so it wasn't that anything I could say about climate change to them. In fact, this one gentleman, he didn't want the government in his life. And he was a very rich man, and he probably had a lot of powerful friends too. So we have to realize that there have been times like this with other political controversies and in the past where there are people with a lot of money fighting it, but with time, it's the citizens that eventually your politicians want to be elected again. And so with time, they will realize that it is a problem and that the votes make a difference. They should start changing their policies. A good example in the US of a group that's already realized climate is changing is our US military, because they realize what it's going to mean for the countries of the world if climate changes. So they have figured it out. And so I'm optimistic, and we can keep explaining, and eventually it is you, though, that will cause your policymakers to change the way they're thinking about this.
Hola. Yo quería preguntaros, bueno, antes de preguntaros, creo que los periodistas y los políticos lo que más les gusta para alimentar sus decisiones es que la incertidumbre del científico. Y como habláis mucho de incertidumbres, eso les da pie a sacar cosas fuera de lo cierto. Entonces me gustaría que dijerais qué es cierto de lo incierto en el cambio climático. Que diferenciarais entre la certidumbre de lo incierto. No sé si me entendéis. O sea, en el cambio climático habláis mucho de incertidumbres continuamente. En los foros de cambio climático se habla mucho de incertidumbres. Y eso le da pie a los políticos y a los periodistas a poder abrir su abanico de especulaciones. Con lo cual, creo que habría que decir algo cierto de toda esta incertidumbre.
I already said it. The Earth is warming. We're causing it. If CO2 continues to increase, the planet will continue to warm. I think that that's a very certain statement. I'd say in terms of how we interpret that, there are going to be surprises moving forward, and we're going to be wrong about some of the things moving into the future. And smart citizenry, smart policy, builds into any kind of decision-making the chance to make mid-course corrections. And we've seen policy that's been effective at that. Sometimes we think problems are going to be bigger than they are, and if we think of that as something we can make mid-course corrections on, we can make adjustments. Sometimes things are worse. We saw this with the Montreal Protocol and the ozone hole, where what we understood of the problem in the 1980s when we were drafting the original policies to address it, we realized weren't strict enough in terms of how we needed to reduce chlorofluorocarbons in the atmosphere. So that's a great example of something that we used as a mid-course correction, addressed the things that we didn't know about it, and made choices later on to address it. So uncertainty isn't something that should cause us not to act. Usually it's used by people who don't want us to do anything as a reason to not do anything. But we can address uncertainty. There's always going to be uncertainty about the future because we don't have a crystal ball. But we know a lot of things. We can use those things in a practical sense to make wise decisions from a precautionary point of view about expecting the worst or planning for the worst and seeing whether or not it unfolds as we move forward. But those are all things that we're smart people, and we can make smart policies that address what we don't know and what we do know and allow for mid-course correction. So that's how I think of it. But again, to come back to the main point, things are warming. They're going to warm into the future if we keep up business as usual, and we're going to have to deal with that.
I'm going to drop into English, sorry. I think we need to learn to work with uncertainty in decision making. We do it all the time in other arenas. We buy insurance. We buy bonds. We plan for the future. We have to work with uncertainty every time that we get on our bicycle in the city or drive our car. So I think if we just need to learn to work with uncertainty.
So, in fact, there is a whole economic branch that is working with the problem of uncertainties. These are the insurances. And in fact, the insurances, and especially the big reinsurances, so Munich Re, Swiss Re, that's huge companies in the world that are dealing with this hurricane damages. So we're talking about billions. And in fact, they are very much interested in knowing more about climate change. In fact, most of them have their own scientists working on the topic. In Switzerland, Swiss Re is working together with scientists to know more about the future and climate, because this is their business plan. If they don't know what's going to happen in the future, they're going to make provisions that are not that good, and they will do less money, because if they underestimate the potential damages of global change, then they will have to pay more damages and they will get less money. So I think for many people it's very hard to think and to work with uncertainties, but there are already branches of economy that are already dealing with this problem, because they are really, it's a big problem for them.
Okay, so when the 8 of us came up here and sat on the stage earlier this evening, we all threw sentences at you that were traps that were designed to foster debate, and it's great that we've succeeded in starting debate, and I think you're throwing some traps back at us, which is wonderful. In terms of uncertainty, it's important to understand that the language of science is different to the language of politics, that uncertainty is a fundamental part of science. I mean, science is an empirical process. It works by developing hypotheses or theories, and then we throw evidence at our hypotheses and see if we stand up. And over time, the more and more you throw evidence at your hypotheses and they survive that test, the more robust your theory becomes and the more confident you can become. And I think as far as climate change goes, people have been confronting that theory now with a lot of evidence for a long time, and it's always held up. So I think we can say, with a very high degree of confidence and with a very high degree of certainty that climate change is real.
Yo tenía una cuestión que...
Yeah, I just wanted also to comment on the uncertainty. And yes, I'm Martin Whitman, working in the UK. We're very, very sure that climate change is happening and that we will see more of it. But one thing we need to understand is that on the local level, the uncertainties are higher. So, I mean, you asked us to say certain statements about our uncertainty. One is the uncertainties on the local level, here in Madrid or wherever, are higher than about global mean temperature. And the public needs to understand that, and we need to communicate that. And it doesn't mean climate change is not happening. And it's not necessarily a bad thing, because as people on the panel here have already commented, we can deal with it. It's not a bad thing. We just need to figure it, to include it in our thinking.
Yo tenía una cuestión que yo oigo muchas veces por ahí decir que muy bien con ese incremento de CO2, pero que como saben los científicos que ese CO2 viene del tubo de escape de mi Volkswagen, que tiene una marca específica esa molécula. ¿Cómo sabemos que no viene del fondo del mar o del océano o del permafrost producido por un forzamiento externo solar, por ejemplo? Entonces, yo echo mucho de menos en esa presentación y hablando del tema de cómo comunicar el problema, de alguna forma dejar claro por qué ese aumento de CO2, ese aumento de nivel del mar, cómo sabemos que es antropogénico.
Yeah, so for the kind of fuel combustion that you actually use for heating it, and the thing is relatively easy because we know how much fuel there is consumed within 1 year, and since that is going just to heat and to produce CO2, that's a budget, and we know the numbers that come from that globally. We have an understanding more or less how that is distributed in the system, and we are more and more also learning how to measure. So there are even measurement sites out to observe kind of what carbon is going, for example, into the forest, what carbon comes out of certain regions. So in that part, I think there is a relatively good, we are really certain that we know at least the numbers we are talking about.
I'm excited. This is a science question. Johan is definitely correct. The other thing that we know is that the carbon in the fossil fuels that we burn is different isotopically. So its chemical composition in terms of its how heavy or light it is different from the carbon that's in the atmosphere. And so in addition to knowing carbon budgets, we also know that the atmospheric CO2 is changing in its chemical characteristic relative to what it would be if we weren't releasing these fossil fuels that we were burning. So the carbon we can track, we actually can see is consistent in how the isotopic composition of the carbon in the atmosphere is changing relative to if it was coming from another source.
That was exactly the point with what I said, that it would be very interesting for the communication problem to state this thing in a communication for this context. Thank you.
So I study isotopes, and I love them. And I will tell you that when the people at the wedding come up to me and ask me about this, they don't want to hear about isotopes. And that's usually because they're very annoying to explain without drawing diagrams and stuff. And so I think that's a challenge for our communities to learn how to communicate that a little bit better. But yes, the answer is that the chemical composition of the carbon dioxide is very distinct, and that's how we know.
Yo creo que nos estamos quedando sin tiempo. Entonces estaría fenomenal quedarnos aquí hablando un poco más sobre lo difícil que es la comunicación en ciencia y cómo desgranar los misterios del IPCC, pero creo que no podemos seguir abusando del tiempo que tenemos. No es culpa nuestra. Y entonces, a no ser que haya una pregunta así que sea muy urgente, que uno no se pueda ir esta noche a la cama sin haberla respondido, pues sí, venga, vamos allá.
A ver, ¿cómo relacionaría el gran debate que genera el cambio climático con un histórico debate que es la educación? ¿La implantarían como enseñanza reglada? ¿Cómo educarían a la sociedad para abordar este problema de que los políticos parece ser que no nos lo solucionan? Entonces, si pueden contestarme esta pregunta, ¿no? ¿Cómo relacionar el tema del cambio climático con la educación? ¿Cómo educaríamos a la sociedad para un futuro mejor? Gracias.
Dice Laura que la respuesta a esta pregunta seguro que va a ser breve. ¿Quién la
Bueno, a lo mejor digo algo que no va a sentar muy bien, pero en el fondo los políticos, la clase política es un reflejo de la sociedad. Es algo que no queremos admitir, pero son un reflejo de la sociedad. Nosotros al final los votamos. Por lo tanto, argumento, ¿cómo? No sé, ya lo dije, pero porque es una crítica hacia todos. Cuando criticamos a la clase política no estamos criticando a todos. Argumentar que hay que educar la sociedad de alguna manera para que los políticos entiendan lo que tienen que hacer, yo creo que eso no es una forma adecuada de ver las cosas. Ya la base científica ya se conoce bien. No hay, digamos, que convencer más a los políticos. Hay un ejemplo claro, por ejemplo, es el país donde yo vivo, en Alemania, donde hay un consenso al 100% de que el cambio climático está ocurriendo, que hay que hacer algo contra el cambio climático, y sin embargo, ya hay un consenso entre el gobierno y la población, en todos los sectores sociales. Y sin embargo, las emisiones de CO2 siguen aumentando.
Bueno, rápidamente una pregunta científica. ¿Podríais decir algo sobre el hiatus, sobre los últimos 10 años de parón de cambio climático? ¿No? ¿No es conveniente? No, eso y... O sea, una reflexión porque uno, metiéndose en un poco... Bueno, solo una reflexión. Si pone cambio climático en español, al menos, la segunda entrada que sale en Google es un blog de un escéptico que hace demagogia por todos los lados y tal. Y entonces, leyéndolo un poco, uno se da cuenta que a veces tienen argumentos que pueden parecer convincentes. Por ejemplo, con respecto del parón y del hiatus y tal, él da algún link así para la explicación que se ha dado en la comunidad científica últimamente. Parece ser que está asociado con un fenómeno de la niña prolongado en los últimos 10 años, que es una cosa difícil de predecir en los modelos climáticos, porque no todos se acoplan a la variabilidad interna y tal. Pero lo que es un poco llamativo y que decía este hombre es que si uno se fija en las proyecciones de la IPCC, se da cuenta que la temperatura actual está en la gama inferior de la incertidumbre, incluso por debajo de la variabilidad natural. Entonces, la pregunta es, si la variabilidad natural, si esta temperatura está por debajo de la incertidumbre, incluso contenida en la variabilidad natural, y la respuesta al hiatus es variabilidad natural, ¿qué está pasando con los modelos? No sé si me explico bien, pero...
I can't find you. Oh, here you are. I'm Gabi Hickel, University of Edinburgh. So when you are, when the spring comes and you have a cold spell coming into your spring, do you think that the spring is not coming because of your cold spell? So I think we are dealing with a lot of variability in weather. We are used to it, and also in climate. And so we can't expect that it's just because CO2 is going up monotonically. Climate is just following like a train, because it is so much else going on, so much variability. The weather is different in different places, and so you can't expect it to just monotonically increase. Does that make sense?
But what I meant, I mean, I don't know. I don't want to offend that, but no. What I wanted to say is that, let's say that the hiatus, the last 10 years of plateau in the warming, with increasing CO2 in the atmosphere, is caused by something internal as La Niña event, as an unusual amount of La Niña events. But that information should somehow be contained in the projections within the range of natural variability and salinity that Jason showed at the beginning. But when you look at that curve, you see that the last years of temperature are below that range that Jason showed. So that's my question. Why is that? I mean, I understand that the pause is caused by La Niña, but why the projections of the model doesn't fall in the range, in that range? That's my question.
It's a really interesting question, and the IPCC author team has been talking about this for a really long time, how to communicate this. And the answer that we have given is that it's partly variability, as we said, and partly it might be that the models don't have all the information they need. For example, the models don't know that the sun was undergoing a quite long minimum in 2008. The models don't know that there has been a bit of background volcanic events. And it's all tiny things, but it just makes the difference between being far outside what the models do and being within a reasonable range. But it is a really interesting scientific puzzle, and if it keeps going for a lot longer, then we have to look very deeply at what's going wrong. But right now, it's very consistent with our understanding still.
No.
tenemos que llevar esto a un final, el edificio cierra pronto y os quiero poner durante todavía unos minutos en las manos de Laura. No os vayáis todavía porque aún hay más.
Buenas noches. Lo mío va a ser un experimento muy corto, ¿vale? Porque lo que queremos es, además, justo los que todavía no habéis podido hablar, que lo hagáis ahora, ¿vale? Entonces, para eso vamos a hacer una cosa muy chula que se hace ahora en la universidad. Y, bueno, quiero que os metáis en todos esos móviles que habéis silenciado y que habéis guardado en los bolsillos, los saquéis ahora y os metáis en esta página web, ¿vale? www.pollev, lo tenéis ahí, .com, ¿vale? Entonces, si esto funciona, vamos a hacer un experimento. Vamos a ver en tiempo real realmente cómo de contentos os vais de aquí, ¿vale? Entonces, bueno, si tenéis Twitter, lo hacéis por Twitter. Yo no entiendo nada, ¿vale? Pero será con el @pool y... Espera, que no funciona.
No, it's starting.
No.
Maybe people haven't entered anything yet.
No, it's because... Wait a moment, espera un momento.
Se ve que estamos todos ansiosos para contestar, pero está Laura organizando el sistema para poder hacerlo.
There's a lot of potential reasons,
En estas situaciones la familia siempre es una ayuda muy importante. Un poco de paciencia.
Vale, ahora sí que podéis votar, ¿vale? Os metéis en pollev y marcáis el código que se corresponda más o menos con la respuesta. ¿Vale? La pregunta sería, ¿ha respondido esta actividad a lo que esperabais? Y podéis contestar que ha estado mejor de lo que esperaba, cual sería muy chulo. Era justo lo que estabais esperando, mira que majo el primero, es un grande. Bueno, ni fu ni fa, o esto que es lo que es, si lo sé, no vengo, me han engañado. ¿Vale? Esto nos da una idea, además, luego, pues si lo queremos repetir, pues... O no. Vale, la respuesta es buena. Vale, esta ha sido de prueba, ¿eh? Ahora vamos a las chulas. Ay, qué bien, contestáis bien, ¿eh?
¿Alguien quiere decir algo? ¿Tú quieres decir algo, Edmundo?
Bueno, a mí me da un poco de pena que se termine esto, pero como han dicho que la azotea sigue abierta para tomar una cerveza y discutir las cosas, pues es mi propuesta.
O sea, que se te ha hecho cortísimo.
Bueno, abortamos misión, yo creo. Vale, pues... Bien, muy guay, porque esta es la última y es la que me apetecía contaros, ¿vale? Bueno, la pregunta la leo es... ¿Crees que das igual valor a todas las fuentes de información que recibes a la hora de informarte sobre el cambio climático? Entonces, no hago distinciones porque todas necesitan recibir o todas tienen la misma importancia, me marcáis ese código. Yo no tengo por qué decidir qué fuentes son más válidas porque eso es trabajo de los medios y yo no tengo por qué entrar ahí. O intento ser crítico con la información que recibo, aunque a veces me resulte más complicado, ¿vale? Tiene un poco de trampa, pero me gustaría que respondierais lo que realmente pasa. Claro que listo soy. No pasa nada, si sois sinceros. Vale. Bueno, pues esto es muy bonito, porque esto es lo que realmente querríamos que pasara, y esto era el objetivo de esta mesa redonda, es decir, vale, hay muchas fuentes de información, pero tenemos que ser un poquito críticos, porque nos van a venir muchas informaciones y lo ideal sería que las pensáramos nosotros. De aquí no intentamos daros un mensaje de nada, de cómo tienen que ser las cosas. Lo que queremos es que penséis, que llegado el momento os vengan diferentes informaciones y seáis capaces, seáis críticos de saber, de entender dónde está lo verdadero y dónde no, ¿vale? Por lo demás, pues no sé, yo creo que así lo dejamos todo, que nos encanta que hayáis estado aquí y que ojalá lo repitamos.